I'm glad to see that you're practicing and getting ready for your test. I'm going to go ahead and show you how to do these questions, so please follow along and then pause after each question so you can try the next question by yourself, then go ahead and start it again so you can see how to answer them. Question number 1 says, given the table, list as ordered pairs. So remember, an ordered pair has to have an X and it has to have a Y. So I'm going to take the first X value, which is -4, and I'm going to match it up to its Y value, which is -2. And you've just created an ordered pair. The next ordered pair, take his X, -1, take his Y, -7, and you've just created an ordered pair. Continue for the remainder of the table. 0 matches 5, 5 matches 5. The second part of this question now says list the domain. Remember, the domain happens to be the X values of your points. So you can either look at the points themselves to find the domain, or you can go back to the table and look at the table for the domain. Just remember, only list each number one time if it happens to repeat in the list. So I'm going to go ahead and start with my -4, then I'm going to hit my -1, then I'm going to hit my 0, and then I'm going to hit the +5. That is the list for my domain. Finally, we have range. Range, remember, is the Y values of your point. X is the domain, Y is the range. So as I look at my points, this second number happens to be the range. I can look at my table. Remember, the Y, again, happens to be the range. We're only going to list each of these numbers one time, just in case they do repeat. So I take -2 and I put it in my list. I take -7 and I put it in my list. I take 5 and I put it in my list. And then I take, oh look, it's a number 5. It's repeated. I'm not going to repeat that number in my list. So I'm going to close it off, and that is my list of range. Finally, the question says, is it a function? How do we tell if things are functions? Well, we can graph the points and do the vertical line test, making sure that it only crosses one point at a time, or we can just look at our domains. Remember, to be a function, the X can't repeat. So if I look at my X values, 5, 0, -1, -4, none of the X values repeat. So yes, this happens to be a function. Please pause the video and then try question number 2. All right, I'm glad to see you've come back for question number 2. Question number 2 and number 3 ask you to find values for a function. If you look closely at problem 2, it says f of x equals 2x squared plus 4x minus 6. And it wants you to find the value for f of 3. This basically means you are going to replace this 3 every place you see an x in this problem. So this becomes 2, and then remember, 3 is going to go into a parenthesis, squared, plus 4, 3 is going to go into a parenthesis, minus 6. And now we're going to follow order of operations. Order of operations say if you have any parentheses with stuff inside of it, then you should try to get that stuff done first. We don't have anything inside but the number 3, so we're going to head straight to exponents. Exponents. Do we have any exponents in this problem? Yes, we do. Right here sits 3 to the second power. So we're going to rewrite the 2, then we're going to bring down a times symbol because a number next to a parenthesis is times. 3 squared happens to be 9. Then we've got 4 times this 3, subtract that 6. According to the order of operations, we now do multiplication and division. Please remember, though, it goes from left to right. So we start at the beginning of our problem, way over here. If we come across any multiplication, we do it. As we continue, we do the next set of multiplication. And then finally, addition, subtraction, again from left to right. So 18 plus 12, that's 30, and 30 take away 6, the answer is 24. So that would be the answer for problem number 2. Go ahead and pause the video, and let's try problem number 3. Come on back when you're ready. Oh, you're back. Okay, problem number 3 is a little different. Problem number 3 says you have the function g of x equals 2x minus 5. But please take a look at what they want you to find this time. They don't want you to find g of a number. Notice they have g of x still sitting in there, but this time they put an equal sign and they wrote the number 7 outside. So here's what that means. This function, g of x, this 2x minus 5 g of x function is going to equal 7. That's what this means. Your job is to solve that equation. So we're going to add that 5 to the other side. That's going to give us 2x equals 12. And if we divide by 2, we're going to find out that x equals 6. So g of 6 will give you an answer of 7. That's how they expect you to do problem 3. It's kind of backwards from what we're used to doing. You don't plug in for the x. You now know what the answer is. So work backwards to find out what it was. All right, pause the video. Try number 4. All right, so you're back. We're going to go ahead and try question number 4. And number 4 has lots of parts to it. We've been working on sequences, so let's hope we can all answer these questions. First question it asks is, what type of sequence is it? So as I look at the -1, moving towards that 3, I notice that if I add 4, that's how -1 turns into a 3. What about 3 turning into a 7? Do I add the same number, the common difference? I do. 7 plus 4. We have just figured out that by adding, that makes this an arithmetic sequence. Now, if it's an arithmetic sequence, that means I should be able to tell what the first term is. I should be able to tell what the common difference is. So let's look at our sequence. Isn't this guy right here, -1, your first term? We are going to let A1 equal that -1. That's our first term. This letter D stands for a common difference. What number are we adding every single time? We are adding a 4, so we're going to put a 4 right there for common difference. If you look at the next question, though, it says, what is a general function for this sequence? Well, first of all, it's arithmetic. Arithmetic means A sub n equals A sub 1 plus n minus 1 times d. All I need to do is plug this information into here, and I will have a general function. So let's try that. A sub n is going to stay like it is. But what is A sub 1? A sub 1 is -1. Plus, n is going to stay just like it is. But what is d? D is a positive 4. This is the general equation. Now the last thing is it says find the 25th term. So you are literally trying to find A sub 25. That means to me that n has now turned into a 25. So all these n's that you see are going to turn into 25s. So we have A little 25 equals -1 plus, what's n again? Oh, 25 minus 1 times that 4 on the end. What's 25 minus 1? 24. We are now going to multiply 24 times 4, so let me cheat a little and come up here and do that by hand. 4 times 4 is 16, carry the 1. 4 times 2 is 8, plus that extra 1 is 96. So I have a -1 plus 96. And if it's negative and positive, they subtract. My answer is going to be a positive 95. So your 25th term is a positive 95. All right, you're now ready to try question number 5 on your own. Same idea, except this time the sequence has changed. So pause the video and go try problem number 5. Oh, hey, you guys are quick. All right, so we've got 2 questions left, getting us ready for our test that we're going to have on Friday. So let's try question number 5. Number 5 gives us the sequence 2, then 6, then 18, then ... So the same questions are being asked. Is this arithmetic? Are you adding or subtracting the same thing to every group? Is this problem geometric? Are you multiplying or dividing something to every term? Or finally, it could fall under the neither category where it's doing something funky, but I think we figured it out. What is the 2 doing to get to a 6? Well, it could be adding 4, but are you going to add 4 to get from 6 to 18? No, this is definitely not arithmetic. So let's try geometric. What could have the 2 done to become a 6? It could have multiplied by 3. What can the 6 do to become an 18? It could have multiplied by 3. So at this point, we have discovered it's a geometric sequence because we're using the same multiplying number every time. So here we go with our steps. Letter B. What is a sub 1? A sub 1 is the first term, which is the number 2. Then it wants to know what is the common ratio. What are you multiplying to every term? You're multiplying a 3. Finally, it wants the general function. What would this look like if everyone in your class needed to use it to find their specific term? Well, we start off with a sub n equals. What's the first term in the list? It's a 2. But instead of adding like we did on the previous problem, geometric functions multiply. So we're going to multiply, and instead of using the common difference, we're going to use the common ratio, which is 3. Now we're going to have to deal with the exponent part of it, the n minus 1. This is what we would call the general function. So if I ask you now, problem 5, letter E, to find the 6th term, what have we just told you? 6th term, what does n equal now? It equals a 6. So here comes our math. A sub 6 equals 2 times 3 to the 6 minus 1. All right, order of operations, 2 times 3, what is 6 minus 1? That's a 5. Order of operations, exponents, what is 3 times 3 times 3 times 3? Well, 3 times 3 is 9. This 3 times 3 is 9. 9 times 9 is 81, and 81 times that 3, 81 times 3, 24, 243. And now all I have to do is multiply that by 2, and I will have my 6th term. So 243 times 2, our 6th term is 486. That's what our 6th term is. All right, lots of sequencing, lots of formulas. Please make sure you memorize those generic formulas. Pause the video, only one more question left. All right, we've head to question number 6, and I'm going to go ahead and draw this graph for you very quickly, but I want to point out some things as I'm trying to graph it. I need to know where is the point where this line crosses the y-axis. Does it cross it way up here in the positive world, or does it cross it way down here in the negative world? Where does that line cross the y-axis? Well, I hope you all say it crosses at -2. Right there, that line is crossing at -2. Now, before I can actually draw the line, it would be helpful if I knew how far up and over, if I knew what the slope was to this problem. So put your finger on that -2, and would you agree that if we went up 1, went up 2, went up 3, and then moved over 1 point to the right, that we would have a nice, perfect little line going like that? Do you guys see that there is a point sitting right there where they cross? Kind of right there? All right, so this is the line. Now we have to write the equation that goes with it. So please remember, a generic equation is y equals mx plus b. What is the m? The m is the slope. The m is how you rise and how you run. You just described that to me. Didn't you say that you had to go up 3 places and you had to go over 1 place to get to that next point? Your slope is literally a 3. Now, do you see this letter B? This letter B is called your y-intercept. That's the point where your line is crossing. Isn't your line crossing at a -2? We're just going to turn this point into a -2, and ta-da, you have yourself a function. All right, well, I hope you go home tonight and redo all these questions again. Practice them, get ready. Your test is on Friday, and it's your second test of this 9 weeks. I really want you to do well. So maybe go to Math Excel. Practice those sequences. Practice those domain and ranges. Do these problems again. Good luck, and I'll see you tomorrow.